Okay, this is Mr. White here. We're going to solve this induction problem. So we first need to show that it's true for n equals 1. So n equals 1. We get 7 to the 1 minus 4 to the 1 minus 3 to the 1. That equals 0. But we know that 0 times 12 is still 0, so that is divisible by 12. Let's just go ahead and do it for n equals 2 to be convinced. Oops. Whoa. N equals 2. We get 7 squared minus 4 squared minus 3 squared. So that's 49 minus 16 minus 9. Minus 9. I think that's 24, which is 2 times 12. Okay, so now we assume true for n equals k. So we have 7 to the k minus 4 to the k minus 3 to the k equals 12 times some number. We'll call it a. Now we need to show true for n equals k plus 1. So this is saying that 7 to the k plus 1 minus 4 to the k plus 1 minus 3 to the k plus 1 is some sort of 12a prime, something like that. So this is our goal right here, and this, in some form or another, is our substitution piece. I'm just going to pick one of these values here. I'll pick 7 to the k because they can turn all positive. So 7 to the k equals 12a plus 4 to the k plus 3 to the k. So I get this. Okay. I'm going to simplify this step down here. Say that's 7 times 7 to the k minus 4 times 4 to the k minus 3 times 3 to the k. Okay, so now for my substitution, I'll take out 7 to the k and I'll put in this big mess up here, 12a plus 4 to the k plus 3 to the k, and then minus 4 times 4 to the k minus 3 times 3 to the k. Alright, almost there. So 12 times 7 is 84, hope that's right, plus 7 times 4 to the k plus 7 times 3 to the k minus 4 to the k minus 3 to the k. Okay, so now we can do some common terms here. We've got 7 fours to the k's and then negative 4 of them. And then we have a couple 3 to the k's and a couple more 3 to the k's. So if we put all those things together, we get 84a, 4 to the k, 7 4 to the k minus 4 4 to the k is 3 4 to the k. And then putting these 3 to the k's together, I get 7 minus 3, which is 4 3 to the k. Alright, so now we know the 84a is divisible by 12, but the question is are these pieces divisible by 12? And this is actually a pretty tough next step here. 84a, now check this out, we take the 3 times 4 to the 4 to the k minus 1. And that's 3 times 4, which is 12. And then I can do the same technique over here. 4 times 3 times 3 to the k minus 1. And I'll just write it up here. We get 84a plus 12 4 to the k minus 1 plus 12 times 3 to the k minus 1. And so we get 12, 7a plus 4 to the k minus 1 plus 3 to the k minus 1. And that, ladies and gentlemen, is it.